Okay, so today we are going to start on the new chapter. We are going to start on the first section, which is the different components of the blood. Okay, different components of blood. Okay, so what are the different components that you need to know for your syllabus? Okay, so this is copy and pasted from the syllabus document. So you need to know, okay, first red blood cell, the first component is red blood cell. Second component is plasma. Third is white blood cells. Fourth is platelets. So we are going to look at each of them in detail. What do I mean by in detail? Okay, you need to be able to describe their roles. Okay, in the transport, of substances by the circulatory system or in the circulatory system, and what are their roles in defending the body. Okay, so we are going to look at each of them more in detail. So for red blood cells, we are talking about oxygen transport. Plasma is more of transport of blood cells, ions, all these things. So later I will talk about it. White blood cells is more for the defense part. Okay. Then platelets is also more towards the defense. Okay. So the first two is more for transport. Red blood cells and plasma is more about transport. Okay, when we describe the function of red blood cells and the blood plasma, is more related to the transport, okay, function. White blood cells and platelets is more towards the defense side. Okay, so let's take a look at the first one. Okay, the first one should be completed very quickly. Okay. Now, red blood cells, okay, can someone tell me, okay, what are the features, what are the structural features of red blood cells? Okay, biconcave in shape, what else? Lack of nucleus, very good. Contains hemoglobin. So what is hemoglobin? Okay, it's a red pigment. What else? What else do you know about the red pigment? What else do you know about the red pigment? Is it a protein? Is it a fat? Or is it a starch molecule? Is it a carbohydrate, protein, or fats? Hello? Can someone answer my question? Is hemoglobin considered a fat molecule, a protein molecule, or a carbohydrate molecule? Protein. So hemoglobin is, you should also know, is a iron containing protein. Okay. Now this iron containing protein, sometimes this iron, you will have this, it's called the heme group. Okay. So sometimes you read some assessment book or extra guidebook that you buy from outside, or maybe when you read your textbook, okay, you will see this word heme group. Okay. Now, so what is the function of the red blood cells? What is the function of the red blood cells? Very good. You should learn this. You should know this in the cells chapter. We already learned this in the cells chapter. Okay, so it's to transport. Okay, it's to transport. Okay, don't disturb people. Okay, so red blood cells, okay, function is to transport oxygen molecules from the lungs to other parts of the body. Now, in order for the red blood cells to perform this function, it requires the hemoglobin. Okay, the hemoglobin is the one that will bind to the oxygen molecule. Very good. Okay, bind to oxygen molecules. Okay, so then I hope you all still remember why. Why is it that red blood cells don't have a nucleus? Why is it that it doesn't have a nucleus? It has more space to transport what? No, it's not transport hemoglobin, transport more oxygen. Okay, so the lack of nucleus, okay, can contain more hemoglobin. Then because it can contain more hemoglobin, then it can transport more more oxygen. Okay, can then what is so important about the biconcave shape? Very good. So this one is to increase surface area to volume ratio. Okay, increase surface area to volume ratio of the red blood cells. Okay, the purpose is to allow oxygen molecules to diffuse in and out of the red blood cells faster. Okay, to allow oxygen molecules to diffuse in or out of the red blood cells faster. Okay, so we are done with the first component of the blood. Okay, we are done with the first component of the blood. So that's the red blood cells, because this one, actually most of the things you have learned in the cells chapter. Okay, then next we are going to look at the blood plasma. Okay, next we are going to look at the blood plasma. Before I continue, I noticed some of you are doing something that you're not supposed to be doing. Oh, you're writing down the notes. Okay, good. At least to clarify. Luckily, I haven't start screaming at her yet. Okay, can? Okay, next time you all need to do something this, please tell me beforehand, because I really don't want later I scream and shout at student for the wrong thing. Okay, you just need to tell me. I will try my best to believe you. Okay, yeah. Can? I already say already. If you copy too slow, never mind. Later you can loop it 1,000 times and you copy 1,000 times. Okay. Yeah. Let's move on. Now, blood plasma will be a lot of new things. Quite a fair bit of new things. So I need you to pay attention. This red blood cells we already learned already. Okay. So you should know already. This is just a recap. Okay, the second component, let's look at blood plasma. Okay, for your syllabus, blood plasma, they transport. Okay, this is where the carbon dioxide are being transported. Okay, so carbon dioxide gas or carbon dioxide gas is being transported here. Then the next thing that you need to know that is important in your syllabus, urea. Urea is a type of metabolic waste product. The word metabolic is important. If you just say waste product, I have to mark you wrong, because waste product can mean a lot of things, or waste product can be a bit big. Okay, so metabolic waste product. Okay, then the third, actually both the carbon dioxide and the urea, they are metabolic waste product. Okay, what is wrong? What is wrong with me? Okay. I didn't realize I didn't mention that. Okay, so both carbon dioxide and urea, they are metabolic waste product. Okay, and they are both transported in the blood plasma. Okay, then the next important thing that you need to know for your syllabus will be dissolved proteins. Now, the blood plasma contains a lot of dissolved substances. Okay, I am zooming in at the dissolved proteins because they are related to one of the fourth function of the different components of the blood, the platelets. Okay, so later we will be looking at this together. So let's keep this simple first. So one of the dissolved proteins that you need to know is fibrinogen. Okay, fibrinogen is a soluble protein. Nogen, okay, soluble protein. Okay, this is involved in blood clotting. Okay, this is involved in blood clotting. So you need to know, first you need to know this fibrinogen is transported in the blood plasma. Okay, then the blood plasma also contain all other dissolved substances, which I'm not going to talk about. You can go and read your textbook. Okay, I'm just going to focus on some of the more important parts. Okay, so there are other dissolved substances. Okay, so please go and read your textbook. So let's look at carbon dioxide first. Okay, let's look at carbon dioxide first. You're very lucky. You don't have to learn what happens to the carbon dioxide. But I'm just going to touch on a few things with you. Okay. Now, the carbon dioxide, they are transported in the form of, not in the form of carbon dioxide gas. They are dissolved. They will dissolve. Okay, the carbon dioxide will dissolve in the water. They will dissolve in the water that is found in the blood plasma. Then they will form this thing called the carbonic acid, H2CO3. Okay, this is the carbonic acid. Okay, then this carbonic acid will dissociate to give you HCO3 minus and H plus. Okay, y'all should know H plus is hydrogen ion. Okay, H plus is hydrogen ion. Okay, then the HCO3 minus is called the hydrogen carbonate ion. Okay, sometimes it's also called bicarbonate ion. Okay, so carbon dioxide is being transported in the form of HCO3 minus. Okay, so I'm going to write here. So carbon dioxide is transported is transported as HCO3 minus ions in the plasma. Yes. Okay. Let's look at the syllabus. Okay, y'all like to ask me whether you need to know or not. So y'all see here, carbon dioxide. Okay, plasma transport carbon dioxide. So you must be able to describe what is the role of the carbon dioxide. Okay. Not what is the role of carbon dioxide, what is the role of the plasma in the transport of carbon dioxide. So you need to know a bit of this detail. Okay? Okay, now let's come back up again. Just now I missed out on one very important component that is transported in the blood plasma that is related to nutrition in humans. Okay, just now I forgot to mention about the digested nutrients. Okay, the absorbed digested nutrients. Okay, digested nutrients which are absorbed into the blood. Okay, which are absorbed okay, into the blood at the ileum. Okay, so this digested nutrients, they are the glucose and amino acid. Can I? So just now I forget to talk about this. So besides carbon dioxide, urea, fibrinogen, these digested nutrients are also very important. Okay, they are very important in your syllabus. Can I? So we are done with carbon dioxide already. Carbon dioxide, I touched on a bit of detail already. Urea, nothing to talk about. Urea basically just dissolved in the blood plasma. Okay, then dissolved proteins, fibrinogen, okay, all these things. Okay, so we are done with the blood plasma part also. Okay, the main thing that I want to focus on is this bicarbonate ion. Okay, so you need to know carbon dioxide is transported in the form of bicarbonate ions in the plasma. Okay, after it dissolves. Okay, then the next component we are going to look at, let's look at the syllabus again. White blood cells. Okay, so for white blood cells, we are going to talk about phagocytosis, antibody formation, and tissue rejection. Okay, let's finish this part. White blood cells now. Now, for your syllabus, there are two types of white blood cells, only two types. You only need to learn two types. You're very lucky. Next time when you go higher studies, you will learn that there are many different types of white blood cells, and there are all kinds of names. Okay, so now you only need to remember two. Okay, one of them is called the phagocyte. Okay, the other is called the lymphocytes. Now, whenever you all see this word, CYTES, okay, this one have this meaning of cells. Okay, so phagocytes and lymphocytes, they are cells. Okay, so you need to know there are two different types of white blood cells. So they have two different functions. Okay, before we talk about the function, there are some slight differences between them. Okay, structural. Okay, so first thing first, I will draw for you. For lymphocyte, usually is rounded, and the nucleus is very big. Okay, this is the nucleus. So for lymphocyte, how do I know it is lymphocyte? Okay, it's a big circular cell. Then the nucleus also very big, cover entirely almost the entire cell. Okay, so this is how a lymphocyte will look like. Then for phagocyte, they are more irregular in shape. They are usually multi-loop. Okay, so I will attempt to draw it, okay, but my drawing not very good. So it will look something like this. Okay, and the nucleus will not be so big. Okay, the nucleus will be smaller. So it is multi-loop. Okay, each of this is a loop. Okay, so phagocyte have this multi-loop appearance. Okay, so there are two types of white blood cells, phagocytes and lymphocytes. Anyone want to make a guess? What is the difference? What is the difference in their function? Antibiotic, no, good attempt, but not antibiotic. Antibiotic is produced by fungi. Okay, but we don't produce antibiotic, but similar. Another word that is very similar to it. Another type of protein that is found in the body. Hello. Besides antibiotic, what else? What else is produced by the body? By the way, antibiotics not produced by human. It's produced by other cells. Sorry. So what is the function? Yes, what is the function of lymphocyte? Okay, both are part of the human immune system to protect the body from foreign particles, to prevent foreign particles from coming into our body and multiplying. Okay, the foreign particle can enter, but but the immune system will attack them and remove them. Okay, so how do they remove? How do they remove the foreign particles? Okay, they will cause the foreign particles to clump together. Very good. So this is which this function belongs to the phagocyte or the lymphocyte? Lymphocyte. Okay. How do they do it? How do they cause the foreign particles to lump together? How? Okay, I give you a hint. Why the nucleus must be so big? Nucleus is to control cell activity in the cell, right? So there must be something, some activity, or there's a lot of activity happening in the lymphocyte that requires the nucleus, right? So what is one of the function of the nucleus? Okay, like to produce what? To produce something. Okay, I give you a hint. When we need to produce protein in the when cells produces protein, they require the DNA. The DNA will give instruction. The DNA found in the nucleus will give instruction which protein to make. Okay, no, not hormone. So what is the protein that this lymphocyte needs to produce? Antibodies. Yes, very good. Just now someone talked about antibiotic. Okay, it's not antibiotic, it's antibody. Okay, antibodies. Okay, very good. So lymphocytes, okay, the function is to produce antibodies. Now, these antibodies okay, these antibodies will recognize foreign particle, will recognize and bind to foreign particles. Now, when the antibodies bind to the foreign particles, they will cause the foreign particles to clump together. Cause the foreign particles to clump together. Now, after the foreign particles are clumped together, do we just leave it there? Do we just leave them there in the clump state? Give it to them. Who is them? The phagocyte. Give it to them now. Don't you give it to them? The phagocytes will come towards the foreign particle. So these antibodies are very good. I like the throwing out answers. So these antibodies they will recognize and bind to the foreign particles. They will cause the foreign particles to clump together, and they will send out chemicals. They will secrete chemicals, or they send out signal to attract the phagocytes. Okay, to attract the phagocytes. To attract the phagocytes so that the phagocytes will come and engulf and ingest the foreign particle. Okay, so the function of the phagocytes is to carry out. Okay, to carry out phagocytosis. Okay, phagocytosis is to carry out phagocytosis. So what is phagocytosis? So basically, will be to engulf or ingest foreign particle. Okay, this is the first step. After they engulf and ingest the foreign particle, they will then digest the foreign particles. Okay, can so this is the function of the phagocyte. Okay, now tissue rejection. Okay, one last thing before I dismiss you. I know the time. I'm going beyond time already. But let me finish the last part about tissue rejection. Okay, tissue rejection has got to do with organ transplant. Okay, now, so during organ transplant, okay, organ transplant. Now, when a patient do an organ transplant, they get the organ from someone closely related as possible, so that they will not be rejected by the body. You must understand a foreign organ from another person, okay, organ from another person is considered a foreign particle. Is considered a foreign particle by the white blood cells. So the white blood cells will attack by right. They will detect the transplanted organ as a foreign particle or a foreign object. They will start attacking. Okay, but in an organ transplant, you don't want the body to reject the organ. Okay, so usually during for organ transplant surgery, okay, the doctor will prescribe the patient some drugs to suppress their immune system. Okay, so that this rejection, this tissue rejection will not occur. Okay, so during organ transplant, okay, drugs will be prescribed. Okay, will be given to suppress the immune system. Okay, so that the transplanted, okay, the organ which is transplanted, okay, will not be rejected. Which is transplanted, will not be recognized. Okay, will not be recognized as foreign and get rejected. Okay, the moment the body immune system detect the transplanted organ as foreign, they will start attacking it. So that means the organ transplant is a failure. Okay, but doctors don't want a failure, don't want organ transplant surgery to fail, because donated organs doesn't come by so easily. Okay, unless you buy them from the black market, which is illegal in Singapore. Yes. Okay, then I think I will stop here today. Okay.